Hello everyone. The title of this video is Evaluating Functions with Base E. So in this video, I'm going to be doing examples that are taken directly from a free online textbook at openstax.org. I'm in their Algebra and Trigonometry text, section 6.1, called Exponential Functions. And I'm under the heading Evaluating Functions with Base E. And each example I'm going to do is either an example directly from the reading or one of the try it problems from the reading or one of the exercises at the end of the section that's related to this particular objective. Right. So this is basically just an introduction to the number E. I know what you're thinking. E is a letter, but it represents a number, kind of like pi represents 3.14159 da 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 da, right? This is a symbol, E, for Euler's number. Right. And they go over a little description of how E came about. I can let you read this. All I really care that you know right now is what they have in the box here. The letter E represents the irrational number 1 plus 1 over n, that base, to the nth power, as n increases without bound, or as n goes to infinity. So 1 plus 1 over something raised to that same thing, right? 1 plus 1 over n, and then that number raised to the nth power. If you make n larger and larger and larger and larger, the value of this expression approaches what is called a limit, which you'll get into in more of a calculus class. But the limit of this expression as n increases without bound is called E. And the value that is that limit, the limit of this expression as n increases without bound, the value of E is 2.7182881828459045 blah blah blah. It's like pi. It's irrational, they mentioned that. So the decimal goes on forever without ending, without repeating. And here they have an approximation for you, right? E is approximately 2.718282. All I care that you really know is that E is about 2.7, maybe 2.718. But just know that it's between 2 and 3, about 2.7. That's really all I'm caring about right now from you. Okay? So, when I go to my paper here, now this is just, the title of this is just evaluating functions that have the number E as its base. So this is no more difficult than evaluating other functions, right? You plug in an input and get an output. So we're asked in all these to evaluate each function, round to 5 decimal places, right? So that's the nearest 100,000th. So let's take a look at this. First, I'm going to show you the graph of this function. F of x equals e to the x, right? This is an exponential function. The base is e, and remember, e is about 2.7. So I have a base that's bigger than 1, and x as my exponent, right? The input variable is the exponent. So this is going to be an exponential function that's increasing, right? It looks something like this. Has the x-axis as a horizontal asymptote, right? Domain's all real numbers, range is all positive numbers. It looks like any other exponential growth function. I'm going to go to that Desmos website and show you this. Right? So, see again, if you just type in the letter E in Desmos, it pops up as 2.71828182884. Again, it's 459045, blah, 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 right? They're giving you an approximation there. If I just go y equals e to the x, and you're see this exponential function, this exponential growth function, right? It's increasing as you go from left to right. Okay. So, we're just asked to evaluate though, right? Just what is f of 3.14? So that'd be e to the 3.14 power. Now don't put pi here. 3.14 is not pi. It's approximately pi. Like I said earlier, pi is 3.14159, right? And it goes on forever. 3.14 is just an approximation. And we're going to enter this and round to 5 decimal places. So back on the Desmos site here, just simply putting e raised to the 3.14 power. So that's approximately 23.103866, and since the 6th decimal place is a 6, we'll bump up the 5th one to 7. So 23.10387 if I'm rounding to the nearest 100,000th. And that is all we're asked to do. Very simple. So please just know this, at least from this video, that e is about 2.7. And whenever you see this special number e, just know that it's about 2.7. That's really all I'm caring about from you at this moment. Alright, how about f of negative 0.5? Well, that would just be e to the negative 0.5 power. Now this will still be positive, right? Raising a positive number to a negative power still gives you a positive result. Right? The range of this function is all positive numbers. So I'm just going to change the power here in my Desmos calculation from 3.14 to negative 0.5. And you see it's still positive. And if we're rounding to 5 decimal places, that's 0.60653, and then the 6th decimal place is 0, so I'm just going to keep that 5th decimal place as 3. So 0.60653. Back here, and circle that. Great. And then what's f of 3, right? Just input 3 for x. This would be e to the 3rd power. Which again, we're asked to approximate. Now, being that it's an increasing function, it should be smaller than e to the 3.14, right? Because that input's bigger. The bigger the input, the bigger the output, according to my graph, right? So this should be a little smaller than e to the 3.14. We'll see that. So just going back here, changing my exponent just to 3. What's e cubed? And it is smaller, right? It's approximately 20.0855. Those are the first 4. And then you got 3, 6. So I'd bump that 3 up to a 4, right? If I'm rounding to 5 decimal places, right? The nearest 100,000th. So approximately 20.08554. Again, that's it. That's all I'm doing here. Plug in an input, approximate an output. So I just got one more of these. So just a totally different function, but it still has an exponential, it's still an exponential function. You have a numerical base. I know e doesn't look like a number, but it is. It represents a number, right? 2.7 something. To a power with a variable, right? So if you have a numerical base that's positive, and then your power has a variable to the first power, you have an exponential function. And I've mentioned this before, but the minus 0.03 at the end here, all that does is move the original exponential up or down. It'll move it down 0.3 units. And that just takes the horizontal asymptote from the x-axis down to y equals negative 0.3. But you can see that in a graph if you wish. So I'm just plugging in 3 here. What's f of 3? This would be 1.2 times e to the 2 times 3 power, or e to the 6th, minus 0.3. That's 1.2 times e to the 6th minus 0.3. And once again, I'm asked to round this to 5 decimal places. Now I'll just enter this in the Desmos calculator. So let's get rid of this stuff. So 1.2 times e to the 6th minus 0.3. Right, so this is to 5 decimal places is approximately 483 point, and you have 8145 for the first 4 decimal places after the point, and then you got 52. So I'd keep that 5th decimal place as a 5 since the 6th one is less than 5, right? So there we go, 483.8145. And that's all. Right? I didn't want to do too many of these because it's just simply plug in an input, get an output, and you can use a calculator, no problem. Again, the major thing I want you to take away from this is that definition of E, right? What the number E is, this thing here in the box with the number E in it. And just telling you that here's how they get E, right? 1 plus 1 over n to the nth, and you just keep making n larger and larger and larger, and the larger it gets, the closer it gets to this number called E, and this number called E is about 2.7. Just know that, please. Alright, so I'm hoping that, after watching this, you know what the number E looks like. You know it's approximately 2.7 something. And hopefully watching me do a couple of examples, you can easily plug in values into functions with E in it and, around certain numbers of decimal places. Evaluate functions with a base of E on your own. And thank you very much for watching.